starting with what happens once the camera's charged. I originally was going to do a live video, but unfortunately my video camera is not high enough resolution to do close up. So here you can see we take a normal disposable Kodak camera. As you know, cameras used to have flash bulbs that were one time used to produce light to either fill darkness or to to make a photo look better, or maybe you need more light for it in order to catch high speed type things. Anyways, now most of them are an electronic circuit, and a xenon bulb is used to create the necessary light to for whatever purpose they need it for the camera. Here's the back of the camera where I started taking it apart so we can look at the circuit. Let's take a look here, a little better photo there where I've just torn off the back part. I'm going to be going over into here to expose the actual flash as well as the circuit. Here you can see I was able to get it in half, and here we start to see some of the circuit. We get to see the battery, and then here's where the circuit board is, and on the other side we'll see the flash. Here I have the full back of the camera exposed. This is where we really start to see some of what we're about to talk about. Behind the battery up here we're going to see the flash as well as some of the other circuitry. Just another one where I was taking it apart, although you can see right here you can start to see where here's the flash as well as a few other things I'm going to explain as far as the capacitor and this diode and where that goes to. Let's take a look here. Bad picture. Okay, great. Now here we are with the exposed circuit, and here we can see the xenon tube as well as the reflector, the trigger plate, the final transformer, which steps up the voltage even more than the initial transformer. And now what happens here is, as Ben and Mike have explained in previous videos, is we've now charged this capacitor with about 300 volts. So despite the fact that we have a little 1.5 volt battery, through the circuitry, the transformers, the oscillating circuit, we're able to charge this at about 300 volts. Now what happens from there is this capacitor, when we click the button to take the picture, is then triggers a switch, and that releases the voltage that is in this capacitor. I'm going to show the back side of this circuit now to help you explain it a little bit better, in theory, if I can find it. Here we go. So here's the capacitor. You'll notice here that one of the leads of the capacitor follows along here and goes directly to this small transformer. Now I'm going to flip this over and I'm going to show you the other side of where that transformer is. This is that small transformer I talked about. Now what this is doing is literally stepping up the voltage again, similar to what the first transformer did. It's going to step it up from 300, 2 to 300 volts up to somewhere between 1,000 and 4,000 volts. Literally then what that does, you can see it's connected right here to a trigger plate. Now let's talk about the flash. I was under a misnomer that a flash just had to do with setting voltage through a bulb, just like a light bulb. Although it is similar to that, it's not quite like that. Xenon is a very stable gas. It has a full valence shell. It has all the electrons it wants in its shell. It's inert. It doesn't want to do anything. What we do in order to get a flash is, a little better one, to get the flash is we send this huge voltage, 1,000 to 4,000 volts, into this trigger plate. What that does is this large positive region that it creates, this big positive part, pulls the electrons from the xenon atoms that are in this tube. And as it pulls these electrons away towards it, several things happen. Those electrons bump into other xenon atoms and all kinds of things happen. And then this voltage, what happens is it ionizes it, and it allows this voltage that we have here on both sides of the flash tube to pass through, and that's what creates the flash, is all these electrons hitting the other xenon atoms and this voltage passing through. This reflective plate, all that does is just reflect the light out the front of the camera so that it goes towards whatever we're trying to take a picture of. So basically, that's what happens. You press the button, the voltage from the capacitor is sent to this smaller transformer. That little transformer then ups that voltage from 300 to 4, between 1 and 4,000 volts, pulling these electrons away from the xenon atoms, causing the flash, causing a light, causing these atoms to emit light. And that's about all. Okay, upon reviewing my video, I just wanted to clarify a little bit so we understand exactly what's going on in this tube. And just, I don't know, just a little bit better. The trigger plate gets that, those thousands of volts of positive charge when the electricity goes through it. This charge instantly attracts electrons that are attached to the atoms in the tube of the tube of xenon. The negatively charged atoms are pulled out from the atoms as other free electrons are pumped in from the sides. Here we have this, the voltage here to the side as well, as that voltage is pumped through both electrodes in the tube. So this attraction of electrons is what's called ionization. When the electrons hit xenon atoms on their way from the tube to the trigger plate, light is created. So that light is then focused in one direction away from the camera by this reflective plate. So that's the metal trigger plate's job. So if you briefly applied, which is what is happening, like a 200th of a second or a thousandth of a second, depending, I guess, on your shutter speed. You briefly apply this high positive voltage to the plate, and it exerts a strong enough attraction on the negatively charged electrons in the atoms that it's able to do that. And so it pulls them free from the atoms, and once again, like I said, that's ionization. These free electrons have a negative charge. So once they're free, they will move towards the positively charged terminal and away from the negatively charged terminal. Excuse me, I was pointing to the plate there. So away from the positively charged terminal and towards the, away from the negatively charged terminal and towards the positively charged terminal. And as those electrons move, they collide with other atoms, causing those atoms to lose electrons as well. And that further ionizes the gas. So these speeding electrons collide with xenon atoms, which become energized and generate light.